Okay, so in today's proof, we're looking at the angle subtended by an arc at the center of circle is double the angle subtended at the arc of the circumference. So I think with this one, it just feels like what all these funny words here and subtended and that. So if we take, starting at 2 points, A and B. I always do it with my fingers, and I don't know. I'm not going to try and move myself there, but think of starting at A and B. So have your fingers at A and B. And if you trace a line to the circumference, you're going to create or subtend this angle at C. And if you start at A and B and you kind of create these two lines to the center, you're going to subtend an angle at the center. And what this theorem says is that if this is x, then this is 2x. So if that's 10, that's 20, right? If that's 100, that's 200. If that's 1,000, something's gone wrong. Okay, so there's kind of our idea for this one. So let's remove all of that and see how we're going to prove this. Now, there's quite an interesting proof, I think. And the idea behind this one is, I don't know, it seems like we mostly draw radius. So in this case, the only place we can really draw an obvious radius is if we drew from C to O, right? Just because most of our proofs there seems to be a way to do it that way. And we've created two triangles. Now, if we extended this line a little bit further, doesn't matter how far it goes, just further along. Now what we've got is two triangles, and here's where the essence of the proof is going to be. That in this triangle over here, maybe I should do this, well, be clear. So if we've got this triangle on the left, and we do that, we've got an exterior angle of the triangle, and that's what we're going to use. And we're going to do the same thing on the other side, where we've got this triangle over here, and we're going to extend and use this exterior angle of the triangle. So that's kind of the idea. Let's run through it as we go. So if we let, say, this angle here be x and this one y, then if we can show, so what we're going to try and do is if we can show that this angle here is 2x and this one's 2y, then hey, look, that angle in the middle is double the one on the outside, right? So that's kind of our idea. So therefore, I'm going to remove that 2x and 2y, but think, how are we going to get there? Well, these two triangles we've created, and I'm kind of trying to always think, let me just say it slowly enough, because maybe you can kind of preempt the next step, and that would be beautiful. So hence the kind of pause and unusual rambles to go, oh, isosceles triangle. So that's x. Same idea on this side, that's y. Exterior angle of the triangle, I said we created. Exterior angle is the two opposite interior angles added together. So this is 2x, because look, it's x plus x. And on this side, this is 2y, because it's that plus that. And we're done. So the only thing that's left to us is to kind of write those things down. Maybe if we call these angles C1 and 2, and we called this one O1 and O2, then it's just easier to reference, I think. So we can say, let C1 equal Y and C2 equals X. We're just letting those things. That's what we started with. We said, well, whoopsie. Now, I guess before that, we should have talked about constructing that line. I don't know if I can move that down. Oh, that's very handy. First of all, what we did was we constructed this line, CO to whatever you want to call this here. Maybe K, or can't be A or B. So let's call this L maybe. Okay, so CO to L. Let C1 equal Y and C2 be X. Therefore, well, A must be X because of that isosceles triangle we've created. B must be Y because of that isosceles triangle. And this one here, O2 equals 2x because of exterior angle of triangle. And O1 similarly equals 2y. Well, that's also because of exterior angle of triangle. Well, therefore, what we've shown is that angle AOB is twice angle ACB. ACB. So we're done. So that's that. Let's take our way back out with the harmony.